All right, we ready now? All right, so if we look at question 1, which letter represents the freezing point since I did not put numbers on that graph? B. Sorry, D as in dog. I didn't turn around, sorry. D as in dog. All right. This is still the solid. This is still the liquid. This is still the gas. All right. It doesn't matter that the graph is going down. Okay. The solid is still at the bottom. The gas is still at the top. The liquid is still in the middle. Nothing about that changes. Okay. Even though I flipped the letters around. All right. It's still gas at the top, liquid in the middle, solid at the bottom. So this is still going to be evaporation, condensation, and boiling. This is still going to be melting and freezing, right? So if I'm asking where is melting and freezing, the freezing point has to be at D. All right, so where is the liquid cooled at? Well, where's the liquid at? C, and what is the graph doing at C? It's going down, so is it being heated or cooled? It's cooled. That's why the question says cooled instead of heated this time. It said heated yesterday because the graph did what? It went up. Today it says cooled because the graph is going down. So the answer is C, because that's the only place you have the liquid state other than where the phase change is occurring. All right, so where's the boiling point? B. B is in boy.
I'll just walk through the references.
Okay. Just stick it over there on my desk. I'll put it up. Say what?
2 is C.
2 is C. Mm-hmm.
So does it, because yesterday you said liquid is C.
No. Yesterday I had it drawn this way. This was the solid. This was the liquid. This was the gas.
She don't care.
Okay? So number 4. What's surface tension?
It's like force up.
The force that holds adjacent molecules together. What types of compounds have poor surface tension? Non-polar.
I put polar.
Okay, now it says poor. So non-polar. All right, what are the 2 types of solid? Crystalline and amorphous. How do you tell them apart? What's a crystalline? All right, definite geometric shape. It has a definite melting point, a definite melting point. All right, so I could use either of those on the test or quiz. All right, definite melting point, or it has a crystalline or a definite geometric pattern. All right, for the amorphous, random pattern, and it melts over a range of temperatures. I could use either of those. All right, and then the last one we have to calculate. What tells us in the question what formula to pick? All right, the word freezes. All right, now I made it easy in that I didn't include a what in this question. I did not include a change of temperature. I didn't even include a temperature, which should jump out at you that there's no temperature in the questions. That automatically eliminates CP and delta T. All right, so since it says freezes, we know we need HF. Q equals our mass, which is 35.6, times HF, which is 334. So what is our Q? 11,800 and what? 90 joules. If you put 94, it's fine. I didn't hear that, so I just wrote 90. Oh, 90.4, I just dropped it. Yeah.
So will the HF and the HV, they're 2 different numbers, so they will always be the same, right?
They are 2 different numbers, but because the state only wants you to use water, yes, those numbers are never going to change. That is correct. Once upon a time, there was a chart, and you had to find the HV and the HF based on the compound they gave you, but they have eliminated that. Okay? Questions on the elements? All right, let's talk homework real quick.
Yes, let's.
All right.
Let's.
I was confused on number 2 because.
Yeah.
Yeah.
Y'all are gonna be surprised at how easy this is.
Is it the same number? Is it the same one? Okay, good. Good to go.
So in number one, you get an answer of 1,045 joules. Number 2, you get 250 calories. Because you take the same numbers from number 1, because you're using Q equals MCP delta T, and you have a mass of 50, you have a change in temperature of 50, and then they tell you, guys, shut up. You use the specific heat that they gave you in question 2, which was 1. So you put it there, and you get 250. The only difference is this specific heat has a unit of calories per, what was the unit again? Grams over degrees Celsius. I just want to make sure I had the kelvins right. All right, so because this was in Celsius and this was in grams, the grams cancel out, the Celsius cancel out, and you just have your heat in calories. Calories is an American unit. We use it here in the States. Nobody else uses calories. The scientific community uses joules.
Miss Wall, I don't know how I got 250 because I did not.
Yes, you meant 5.
Oh, you meant 5.0. I was like,
Oh, was it 5.0?
no, you put 50
Oh.
times 50.
Oh, 5.
And I was like,
Sorry, 5.
I divided 135 by 4.1, the specific heat. So I don't know how I got 250.
Not a clue.
You just have to get
calculator.
Just good guessing.
I have dirt, but
All right, the rest of them should have been pretty easy. Number 3, 11,690.
no.
Number 4, 192,100. 192,100.
Thank you.
Number 5, 500 or 5,225. 5,225. And number 6, 16,700. Do I need to do any others?
Right, you
Oh,
said.
yeah, you should check it right now.
Go ahead, check it.
I don't need to check it. All right, anybody else have a question on these? Yes, Rosanna.
On number 3, where did you multiply 35 by?
All right, because you're solving for, it says melt. So you're using Q equals MHF. So you're going to solve by saying your mass is 35 times HF is 334. Okay.
I used HV.
All right, you would only use HV if it said evaporate, condense, or boil.
No, it's because I saw ice. So
Oh, ice would be a melt or a freeze. That's a solid to a liquid. Anybody else? All right, you need your orange reference sheet and a calculator. You do not need a periodic table. At least I can't think of any reason you would need one. If you want it, you can have it, but I can't, for the life of me, figure out why it would be important.
You said, what did you bring that reference?
Reference table and a calculator?
Well, my chair is missing.
It'll be fine.
I'm gonna sit there.
It'll be fine. All right, you will, those of you with notebooks on your desk, take them off your desk. So you only have your reference table and a calculator.
I don't even got that.
Maybe somebody will be kind to you.
If y'all want to laugh, you can just put my quiz on the document, Carrie. Okay.
I'm sure no one will cheat on me.
I know that's what I said if y'all want to laugh. Even though
Somebody might be desperate enough.
it is multiple choice, then guessing skills.
You never know.
No,
I even managed to get all the questions on the front page.
Oh,
Please make sure you put your answer on the line. If you just circle, it's wrong.
hurry up, because I got a picture in my head of the graph.
Right.
All right? When you're done, flip it over for me.
Looks like a test.
Not a test.
Miss Wall,
It looks like.
Multiple choice.
well, I got a question when it comes to
Take it and break it up, my dears. You know?
you a real one. Okay.
This is one for Annabelle.
Can I see one because I got a question for it? Oh, never mind. You label it.
Alright, everybody get one? Other than Caleb, because he couldn't find the video, so. I'm sorry, I posted it to the website. It didn't record yesterday. We had a glitch. Say what? Today's the 8th.
First question.
Yeah, it was last semester's.
Yeah, I said you and I realized it was my
Yeah, it was last semester. So I done it deliberately. Huh?
I'm already.
Just skip it, go to the next one, come back.
What is the first one?
Right.
Think about it logically.
No.
What's wrong?
Shut up. Think about it logically.
There's no logic.
Yes, there is.
Have you met me?
Yes, there is.
No.
Correct.
Cough. Oh, this thing moves. I was leaning on it.
It's on wheels, dude.
Oh, you ran out of paper.
There's some white paper in there.
Or you could just use the bag.
I'm not.
Does the compound matter? I don't know.
No. I won't answer that.
Ooh. I don't think it is.
You have to have the procedure and both dates.
You want us to write our external lines again?
I want you to what?
Write the external lines again?
Yes. Didn't I say that?
No.
I'm almost positive I said if you only circle and don't write the answers on the line, you're getting a zero.
Exam or test.
Well, this is the same.
Oh,
I'm almost positive I said that in the directions.
well, just
Sarah Lynn, did I say that? You were my favorite, but you're not anymore.
oh, yikes.
Are we doing favorites now, Rocky? How you roll?
Yeah. Just answer them. Give it your best shot.
Okay.
You do know I don't remember what I put on there, right?
Can you come here real quick?
I did it yesterday, first period. The day before.
Okay.
This is even new
I'm
and fresh.
so awful. I'm scared.
You don't think I got rounded for significant digits or something?
You should have.
Whatever, dude.
Rounded?
Whatever, dude.
Wait.
Yeah, I could have rounded there too.
Hold up, bitch.
That's what happened. Okay.
Sometimes when I get things out of a
Sometimes
test
when I
bank,
feel like being a little.
some test banks round, okay? This one came out of a test bank that I have. Some test banks round, okay? Accept it and move on. Pick the answer that's closest to the one you get and go to the next question. You will see this test bank again.
Wait, as well. So,
What do you want?
quiet. So are these
You're gonna fail.
you?
No, you are,
Why?
because you're rude and I control your grade.
I was asking a question and you said, "What do you want?" Are these two like basically? Are they the opposites? For
I don't know.
For you letter wise.
I'm not going to answer that
But that
question.
determines the answer.
I'm not going to answer that
What
question.
if I you? So it could be right. Mine.
Not going to answer it.
Right.
Think. Mm-mm. So I remember to pick some of the grocery store out. Should be getting close to done.
Whoa.
Yes.
False. No.
Well, I'm done. Can I get some tissue?
Hmm.
I'm done. Can I get some tissue?
I guess. I'd hate for snot to drip all over my counters.
Thank you.
Yep. What if what? Yes. What do you mean you might know? Shh. Pretend it's the exam, and you got to do something. Just give it a guess.
Is this question actually? It's only a guess, but like, I don't even know what the question's asked.
Okay. I'm gonna tell you. It counts. Nine.
Yikes. It's bad.
Okay, okay. Question. Is it?
I don't know. What you think? Put down what you think. You think that's it? Go with it.
Straight, baby.
I only did that time just to see how long it would take you to respond.
You know, there's like, but it'll be straight. It's okay. Chill out.
It was just that time.
What?
This is what I need you to take it from me before I keep.
I'm ready.
Whatever.
I'm not.
Well, you can go ahead and take.
Take it, because I'm
No.
tired of looking at it.
Yeah, I have one more. Keep looking at it.
I definitely
All right,
got it. No. As long as if I get over a 50, I'll be proud.
I give you 3
So.
minutes. That's it.
Can I get a 15?
You know? Because
And that's it.
We just pick those areas.
tissue now.
That's why I pulled my nose ring out last night in my sleep. I hopped up so fast, I found it and put it back in. I was not playing games. I'm not wasting 35 hours.
Okay then.
It was fun as well, because I never came out my sleep that fast in my life. I felt it the moment it came out. Where is it at? I started cussing out my sleep. I was like, dang, shit.
Does everybody put down what they want me to know they know? Put down their final guess.
I think
Is that wrong?
So it's right, take a look at it. Wait a minute.
Alright, pass the board.
Look at it, this
By
one.
the time I get to Dylan, he'll probably have written down what he wants me to know.
Look.
That was my answer.
It could have been open ended.
Y'all always want me to like multiple choice. Why do you think? No, I don't think
Yeah, no, because that was open response.
What's wrong? What are you syringing?
They gave me those box slip bags that I try to sort out.
What you did a syringe for? Well, how are we supposed to
Alright, how are we supposed to know graded surface tension? Jayla asked, what? Polar, not polar. So how are we supposed to figure it out? If it has dots on it. So how are you supposed to figure out if it has dots on it? Well, which one would have dots?
Was it the one with the H? The H can't have the.
H can't have all of there. So N would have
I
dots.
guess. I didn't know how to.
That's your own instruction. If you have enough memory, we've drawn NH3 like 100 times.
Well, we should have had our periodic.
And all of you who stroked out over A, what was the definition of a fixed geometric pattern? So, did you need to know what compound it was? No, all you had to find was the state and which one had a solid.
Oh, there we go.
All
right, I got two right, Don't get that.
11 was A.
It's all. We all failed.
I'm not exempt from the quiz. We talked about all this stuff. I'm not dropping the low grade.
That's what you should do.
11 should be a bonus question.
11 is not a bonus question.
But it should be.
I even talked about it yesterday, knowing it was on the quiz.
Well, no, you said bonus question.
Well, that's y'all's fault.
No, that's your fault.
I can't fix it. Y'all are done and don't want to pay attention. All right, guys, let's see if we can't put some stuff on the next quiz. Some of this will recycle on to the next quiz, by the way. You might have one tomorrow, you might not. It might be on Thursday. What's tomorrow? Wednesday? Might be Friday. I haven't decided. Again, you know how this works. I will post the video. If it doesn't record, I will fetch one from last semester and I will post it. All right? If you're absent, if you missed a quiz, we talked about dates yesterday. They're up here if you forget. The 22nd is the last day for makeup work that's old. This kind of stuff that we're missing this week falls in that old category. So it will have to be made up by the 22nd. Okay? So if Faith misses something in the next 2 days, so she's already said she will not be here for the next 2 days, this falls in the old category, has to be made up by the 22nd. If you're out next week, it falls in the old category. Get caught up, get your quizzes made up. All right? Any questions about that? All right. Yes. Sure. We will test, if we're going to test somewhere next week, and we should be able to get that in by the 22nd. Also, if you missed and need to make it up. Okay? Now, we're going to talk about equilibrium today. We wrote down a definition yesterday. All right? I forgot. You forgot? Now, did I get a lab paper to everybody who's here? Does everybody have the paper so that they could do their pre-lab for Monday? I don't want to be blamed for no one having their homework on Monday. So everybody has the pre-lab paper so they can do their procedure and the 2 data tables for Monday. Going once?
Going twice?
Going twice?
So to know.
Okay. Remember, Monday. Everybody told me we have no AP tests on Monday, so I'm assuming we're good. All right, so yesterday, we wrote down the definition for equilibrium. All right, and before you left, we talked about two important parts.
The equal
All right, I'm not going to write the definition again, but we'll go back to the two important parts. All right, so what do we say the two important parts are in the definition for equilibrium? All right, so we have to have equal rates, and we have to have two opposing processes. Now, just to review in the definition, the two opposing processes can be a physical process or a chemical process. And I'm going to break these apart. Today, we are only going to talk about physical processes. Next week, best guess is Monday or Tuesday, we'll talk about chemical processes. All right, we'll learn to write chemical equilibrium expressions and calculate what's called K, which y'all will like because they're pretty easy. And then we're going to learn how to shift equilibrium, which most of you will hate because there are rules to go with that. And you'll be like, and then you'll come back the next day and you'll all go, I don't get it as well. Okay? So we'll manage our way through that. I can almost guarantee you that you will see questions on chemical equilibrium on the exam. All right? So we'll spend a little time with that. But we're going to start with physical equilibrium in case that's there. The nice part about it is the curriculum says that we're going to talk about liquid vapor systems. Now, I could do this with any kind of equilibrium. We could do it with melting and freezing. We could do it with sublimation and deposition. But since they specifically tell me to do it with condensation and evaporation, I'm going to limit myself to that since we're getting close to the exam. So, just as an example, yesterday, I talked about setting an ice cube on my desk. Now, what's going to happen to the ice cube if it's sitting on my desk? It'll melt, right? Can it refreeze? No. Okay?
Not in here, at least.
Not in here. I think it's a little warm. Okay? It will not refreeze because we melt and we cannot refreeze. There are not two opposing processes. Okay? There is no equilibrium able to be achieved. Okay? We can never have equilibrium for that ice cube. It doesn't matter how long the ice cube sits on my desk, it's never going to refreeze. Does that make sense? All right? So in order to have equilibrium, you have to have two processes. All right? So if we want this to work, we at least have to have a what? A freezer, okay? Or at least a refrigerator that was really cold, okay? But a freezer or a refrigerator would be ideal in order for us to be able to have an ice cube that could melt and refreeze. Sitting here on my desk in this classroom at about 75 degrees, we have no hope of that ice cube refreezing. All it's going to do is melt, okay? Is everybody with me on that? All right. Now, I need to wait on anybody to catch up. Everybody there? Okay. So, the state wants us to look at a liquid vapor system. And they want it to be a closed system. So, we're going to use that, which means nothing gets in or out of our system. So we have some water in a container.
So is this like an experiment?
Yep. We'll make it about 23 degrees Celsius, which is like room temperature. All right? Now, if water is sitting in a container, over time, what's going to happen to the water? It's going to evaporate, okay? So we need to talk a little bit about the process of evaporation, and then we're going to talk about what happens to the water when it evaporates, okay? That's how we get to the process of equilibrium and what happens to it, all right? Because the system is a closed system, can the water leave the container?
No.
No. Most of us, when we talk about equilibrium, evaporation, we're not in a closed container. The Vapor just escapes and goes wherever. Okay? Now, the reason we have to talk about this system is because we have to talk about boiling. That's part of your curriculum. Okay? And you can't talk about boiling without understanding equilibrium. So that's the purpose of this. That's why some of you are going to be looking at me like, why do we need to know this in a minute, Ms. Wall? That's why. All right, so in a container of water, everybody in here at this point knows that water is moving, right? Now, really is in that container. Now, if the water's moving, when it has sufficient kinetic energy, it will leave the surface of the liquid. And I point this out because remember yesterday we were talking about the differences between evaporation and boiling? Evaporation only occurs where? It only occurs from the top. It occurs at the surface, okay? Evaporation begins, okay? Now, so if evaporation begins, are we at equilibrium? Would we be at equilibrium at this point? All right, the answer is no. All right, why is the answer no? Rephrase. You're right in that no, we need what? What's the opposite? What's the opposite of evaporation?
Great question.
Okay, we need condensation. Freezing is the opposite of what?
Melting.
That's right. So the opposite of evaporation would be condensation. All right, you had the right idea, you just used the wrong phase change. All right, we're not at equilibrium because we don't have two opposing processes. We only have, I can't get my S on there. All right, we only have one process going on. We only have evaporation. There's no condensation occurring. Raquel.
So do the two processes have to be naturally occurring, or can it be like the melting ice if you bring it in a, like if you put it in a refrigerator, then it'll be?
Well, it would still be spontaneous and naturally occurring in a freezer. I mean, we wouldn't have to do anything to it. The cold air in the freezer would cause it to happen. Yeah.
So it can be manipulated.
It could be manipulated, yes. Yes, you could manipulate it to make it happen, and that would be fine. All right, everybody caught up with me? Can I turn the slide?
They hurt.
Huh?
Do they like hurt?
What?
Your bruises.
I don't feel this one. It doesn't hurt.
What?
At first
Huh?
I thought that was birth my sisters, but then I was like, I'm pretty sure I've seen this.
Yeah, no, this one's gone away pretty quickly. This is the one I thought was worse. I didn't even know about this one till y'all told me about it.
Oh.
Go figure.
Let's get it.
All right, so evaporation continues. Yep.
Wait, Miss Law, what are the dots?
The vapor.
Okay.
All right, so the vapor continues to build up. All right, so if this vapor is continuing to gather up here, what's going to happen is that, what are you putting in my trash can?
Oh, she's in a box. You
This
know
stuff's
that
gonna
kind of stuff goes
stink.
with Bowers trash can.
This stuff's going to stink all day.
It is not.
It's yogurt.
It does not smell bad. It's just yogurt.
What kind of yogurt is it?
What did we put in the trash can last time and it smelled so
It
bad?
had stuff from
You?
that was
yogurt.
Chick-fil-A yogurt. That stuff smelled terrible.
Oh.
That's why you just don't like healthy foods.
I'm okay with healthy foods. I like strawberry yogurt.
It smelled gross.
What was wrong with you?
It just was like, it was steamed up and it was just like.
It's gonna stink. By 4:30 when Miss Kim gets in here, that stuff's gonna stink.
It's okay, talk to Mom or Mr.
Go to the trash bag, go to the.
Yeah, go swap your trash can with Miss Bowers.
What was
Put it in the back room. Bring that trash can up here.
Put it in the bathroom. The back room. So when you first walk in,
right.
Miss Wall, it is okay.
You sit in here and sniff that bad yogurt all day. All right.
It's just bread.
So when the vapor builds up, all right, what's going to happen up here if the vapor builds up? It's going to condensate. Okay. So what causes the condensation? All right. What happens to cause the condensation? All right. The vapor molecules. That's right. They have to hit each other. All right. Why would they stick together?
Yeah.
What have we learned about that would cause them to stick together? Surface tension. What else? Or something that would have caused them to have good surface tension.
Yes.
All right. Particularly if they're polar, that would really help them stick together. Okay. So the vapor molecules hit each other. They stick together and begin. No, not in here.
You said can't talk about how to wash.
With all the six in
Everybody
here.
look at the.
I didn't want them going in here.
Go say, I can open that drain over here on this first sink.
The water count?
There are seats.
No, that's
Go to the
what
ladies'
I
room.
said.
But I can take the cover off on the sink behind Cecilia and I can turn the water on and make you all squeal with the smell that comes out of that sink because somebody poured milk down that sink that smells bad. Okay? In 3 years' time, it is horrendous. Okay? So no, we're not putting yogurt down it now. All right? I don't want collapse. That doesn't sound right. I'm sorry, I know you're right, Denise. I didn't like the way that sounds. We'll just go with condense. All right. All right. So, are we at equilibrium?
Yes.
Yes.
Yeah.
Because it's condensation.
All right, we have equilibrium. We do have the two processes. All right, so we have two processes. All right, but they're not at equal rates. Nowhere in this description does it say that we're at equal rates. It says evaporation continues and we're just beginning to condense. So, unless the question says, or the description says, point blank, the rates are equal, can you make that assumption?
No.
No.
Never do.
Okay.
Never will.
So,
So the answer is no.
the answer is no. Okay? So, we are not at equilibrium. Okay? You are not at equilibrium. Would you stop shaking that? All right. Has everybody caught up?
No.
All right, we there now? All right. So for the final box, how will you know that you're at equilibrium?
So are we gone?
No, all the water will not be gone. It's a closed system, so the water can't leave. The vapor is trapped inside. The water's trapped inside.
It'll be condensation.
That's an equal amount of vapor and water.
Okay. Now, nowhere in the description of equilibrium, does it say the amounts of water and vapor are equal? Okay? The amounts are irrelevant. All right? Equilibrium is reached. I heard it back there. The rate of evaporation equals the rate of condensation. It has to tell you that in the question. If it doesn't tell you that, you cannot make that assumption. Now, the amount of water and the amount of vapor do not have to be the same. Okay, they're irrelevant. The amounts of water and vapor don't matter. You might have a whole bunch of water and not much vapor and be at equilibrium. For example, you go to Walmart and the store just opens. Pretend it's not for this example.
Say the neighborhood one.
Yeah.
All right, when the store opens, are there a bunch of people in it? No. Okay, a few people trickle in. One or two might come out because they got there early. All right, more people are going in than coming out. Are we in equilibrium? No. Now, are the amounts of people inside the store and outside the store in the parking lot equal?
No.
No. When would we reach equilibrium? When the number of people who do what? Go in equal the people who come out. Do the number of people inside the store ever have to equal the number of people outside the store? No. It doesn't matter how many people are inside the store or outside the store. We're only interested in the number of people going in and coming out. Okay? So if 4 people go in, 4 people have to do what? Come out to be in equilibrium. Number of people going in and going out have to be the same. It doesn't matter if 200 people are inside the store and only 12 are in the parking lot. Okay? If 4 go in and 4 go out, you're at equilibrium. 2 go in and 5 come out, are we at equilibrium? No. Okay? Equilibrium is about rates. How fast we change into gas and how fast gas changes back into liquid. Okay? If the rates of change are equal, you're at equilibrium. The amount of water and the amount of gas don't matter. You could have a bunch of gas and not much liquid and still be at equilibrium. All right, are we there?
Yes.
Now, we're going to play with that in a second. But before we do that, 2 factors affect the rate of evaporation.
That's all.
Yep.
Can I undo my sink and wash my fingers off?
Yep, as long as you just wash your fingers.
Undo my thing. Don't get that everywhere.
Just to open
Okay, 1 factor affects the rate of condensation. Now, what 2 factors affect the rate of evaporation? How fast water will evaporate? Temperature is 1.
Fresh.
Nope. It's the most common answer I get, though. Nope. Volume is not it.
Amount of water?
Huh?
Amount of water?
No.
Contact.
You got a tennis match this afternoon. You need the courts dry. What do you do?
Heat it up.
Wait.
Time.
Blow it up.
Okay.
Right.
All right.
Blow it up.
You don't do anything else if there's a puddle of water?
You step over it. Add heat. You disregard it. You don't care.
Honestly, the sun takes care of
Right.
that.
I'm confused. What?
You just
What?
don't have the
What?
match.
The sun. The sun.
Okay. You want to mop it across the
You
floor.
take the towel and you.
You clean it out. You just like
Okay, maybe y'all
what
will
it
do the
is.
same one.
Like
Evaporation. That's evaporating.
you throw it in the trash
That was
can.
a bad.
Well, we don't know. You can get another now. You swing it, placing it.
You jump in
Where
it.
the
You
sun
play
is
in
on
it.
the mat.
I'd scratch the example. Y'all are clueless. Huh?
Cancel.
That's why
Oh,
I tell
you
it.
don't know? Right.
Postpone.
You just gave us like.
You got a puddle of water on the floor at Chick-fil-A and you need it to dry.
We squeegee it.
You just,
Yeah, exactly. So what are you doing when you
You
squeegee?
just clean it
Oh,
up.
we can't squeeze it.
You're moving the water around and increasing its what? Increase this surface area.
Okay, how does that have anything to do with the tennis court us cleaning it up?
Because once upon a time, if you had a brush or a squeegee, you spread the water out on the tennis court so the sun would do what to
Hey,
it.
I said you squeegee it.
Oh, I didn't hear you squeegee.
Once upon a time, then I went in 1982.
Wasn't quite that.
Give me a squeegee.
All right, but if you do push the water around on the tennis court, the sun would dry it faster for those people who said the sun would dry it. If it's a giant puddle, it takes the sun a lot longer to dry
But
it.
now with Beverly, there's a drop of water on that tennis court. Cancel. Like,
Well, spread the water out and the sun would dry it faster, so you can increase the surface area. Just like if you squeegee it at Chick-fil-A, it will spread the water out. The floor will dry much faster. Now, to answer the second question, you cannot use an answer that's on the board before you all tell me temperature again. All right, you cannot pick an answer that's on the board. You will not most likely give me the right answer I'm looking for, but I will take something that means. Nope. Mm-mm. What affects how fast it condenses? What do you need to affect condensation?
Heat absorbed.
Not a heat absorbed. The what?
plugs.
Surface area.
Nope, not surface area. I told you can't use one that's on the board.
Amount of space.
Not the amount of space. We go back.
Polarity.
What do we need to condense?
Paper.
All right, what about the vapor? What do we need to build up? Okay, what about the vapor?
You need to get move more.
Not move more.
You move the bottle around.
What'd you say, Hallie? Well, they do have to speed up, but that's not what I want.
Don't you just go like this?
Oh, you have to get them to slow.
Stick together? You just wipe it with a paper towel.
What kinetics?
I can. I was hoping that somebody would tell me.
Don't tell us. We don't know. We don't know this topic.
What is the letter start with? Yeah, what does it start
I
with?
told you you wouldn't get the word for
What
it.
does it start with?
What's that?
Condensation.
What'd you say?
What's that condensation?
No.
What was the question?
Compression.
Common
Common number.
Coefficient.
Coefficient number. Connecting numbers. Concentration. What I mean.
Now, what does concentration mean for us?
Number
The
of
focus.
certain area. Right. That's what.
Number what?
Number of particles.
She said concentration camp. All right, it's the number of particles per unit of volume or per unit of space.
I feel like.
All right, so
I just hate so much justice.
for us, the more gas, the higher the concentration.
Anybody want Cheetos?
Somebody want Cheetos? Cheetos.
What'd you do? Just eat the stuff in the bags except the Cheetos?
Exactly right.
Okay.
Oh, did
You didn't know it.
Oh, never mind.
Yeah, give it to yogurt girl.
She was trying to be
Yeah, I can tell.
I feel like
She's gonna eat all the
I just
Cheetos.
ate like more than half of a
party size bag of munchies, but sure wine. Stop it.
So if we go back to,
God, I'm tired.
so if we go back there, if I increase the temperature, what's gonna happen to my evaporation?
Yes.
Increase.
Will it evaporate more or less?
More.
It'll evaporate more. All right, if I increase my surface area, what happens to my evaporation? It'll happen faster. If you spread it out, it'll evaporate faster. Now, for the purposes of concentration, if I have more vapor, will I condense more or less? You will condense more. Okay? There'll be more condensation if you have more vapor. Okay? Sort of like humidity in the summertime. Do y'all know what humidity is?
Hell yeah.
Yeah, water vapor in the air, right? So if you have a soft drink or a bottle of water or a cup of tea or whatever it is you're drinking in the summer, all right, does it sweat more or less than in the wintertime?
More.
More, because it gets more moisture on the side, all right? Because there's more water vapor in the air, okay? It will sweat less in the summer. I'm sorry, the winter. All right, now, anytime there's more humidity, it's going to sweat more. It's pronounced Le Chatelier. He's French.
Le Chatelier.
Le Chatelier. It has a little symbol over it. Now, this is coming back around next week also. All right, and we'll talk about Le Chatelier's principle then too. Now, Le Chatelier's principle says if a system,
You should have wrote that up there and let us try to guess it. That would be fun.
most people tell me it's Le Chatelier's. If a system we say is instead of has. We're not past tense. If a system is subjected to a stress, the system will automatically,
Shut down.
no,
That's what I mean.
readjust
We just go to bed. It's crazy.
to minimize
What if it's breakdown?
the stress.
I don't want to.
All right, so the stresses that we're going to work with will be temperature, pressure, and concentration.
More than half of the parties on munchies.
Annabelle Hush.
Wait, it says if a system is subjected to a stress.
Yep. So if we change its temperature, for example, the system will automatically readjust to minimize that stress.
This is unnecessary.
What is that?
I could readjust to minimize the stress.
It'd be fabulous if we had that ability.
I know.
Now, the stresses that we're going to talk about are temperature, pressure, and concentration.
You are temperature, pressure, and concentration all in one. Give me a reason for my stress.
Now, today, we're only going to do temperature, okay? For physical equilibrium, we're only going to talk temperature. Next week, when we do chemical equilibrium, we will do all three,
Hold on.
okay?
So stress is temperature, pressure, and concentration.
Those are the three stresses we will look at,
So
yes.
that's perfect.
AKA Miss Wall. Because she really did just.
What is P?
Pressure.
All the pressures.
He does not.
I feel like she did that person. I can take a picture of that. Sometimes, you know, Miss Wall really should get something because I love her.
I love her too.
I like to see you cry.
I know.
Oh,
What?
That's.
That's why we should play for the Grinch at Disney.
Actually, what?
Oh my god. That'd be hilarious.
All right.
You get retired and you just move to Florida and work at Disney, like the Grinch.
I don't think I could deal with the temperature.
Definitely can't be Santa.
All right. So let's say that we're at equilibrium, okay? And I'm going to come along and I'm going to add a stress. Okay? I'm going to increase the temperature to 35 degrees Celsius. Now, what's going to happen inside of the closed system when I do that?
Good question.
If we're at equilibrium and I come along and I disturb the equilibrium, what's going to happen in the container?
Evaporation can increase.
All right?
About fell over. Why do you keep drawing the same picture?
Because you have to understand what happens inside the system. We're all good with the particles move faster, right?
Yes.
Particles will move faster.
I
They
swear.
escape the surface faster.
I swear.
And according to Kevin, evaporation will increase. Are we okay with that?
I spelled equilibrium different every single time, I swear.
Are we okay with what he said there?
Yeah.
All right, so let me ask you this. If evaporation increases, what will happen to the amount of water? Okay,
Same.
so the amount
Oh,
of water will do what? I hear decrease.
So are we
That's
talking
exactly
about, like,
right.
liquid water, not
The
like
liquid water, that's right here, this liquid part at the bottom. If we evaporate more, the liquid part has to do what? Are we okay with it has to go down?
Yes.
Because it did what? It changed into what? It changed into gas. All right, so what will happen to our amount of steam or gas?
Is this where our lab's on?
Nope. So our amount of water vapor will do what? It will increase. No, your lab is on calculating specific heat. It's a math lab.
A math lab. Really?
Just for you.
Don't even call it a lab then. 'Cause I think it's
In college, they
excited.
have math
Call it-
labs.
You're going to work with test tubes, zinc, water, Bunsen burners, calculate specific heat.
That's a lab this one. I thought I was just going to question if you call it a lab is around the world
Say
or
what?
something.
Like that
Sure.
one time.
Yes.
Wait, that was. Lord, you think we just want to drop out? Like, it's you was gonna just honestly. You stress me out. You make me don't want to go to school. Like, I remember like in fifth grade, I used to get bullied by kids. I didn't want to go to school, but like it's teachers now. I don't want to come to school. It's hard. Get your life together.
I don't want to come to school because I come to Northville things. And
See, you don't want to sniff it. It's sitting on your desk and you don't want to smell it either.
Will they use a pad? Is it purple like a color?
No, look at her like it's just saying.
Yes.
But you said.
I don't want to wash it out in my sink. You wash it out during the change of class.
You said go to the bathroom.
Yeah, like during the change of class.
I didn't say go to the bathroom.
You can sniff it the rest of the day for all I care.
Well, I was-
You already put it in my trash can.
I'm not using the pass because you told me to go to the bathroom and now I gotta use the pass and I didn't even ask. I mean, it should be yours too. Like, it is.
All right. So, if the temperature went up, all right. All right, so we're here, right? Evaporation increased, right? You said I made more vapor. So, if I have more vapor up here, what's going to happen? What's going to happen?
Not equal.
All right, we're not at equilibrium anymore. That's right. Okay? Let me go back here because I just assumed something and I probably shouldn't. Are we at equilibrium anymore?
No.
Okay. I assumed y'all knew that, but maybe I should write that down.
You should never assume anything in this class. We think a lot of things of us and then we disappoint.
Okay, well, I'll write it down then.
AKA my life.
All right, I'll write that down so that Annabelle's got it in her notes if she chooses to write it down. But there's for the rest of you too. Okay? We're not at equilibrium. No, we're not. That's why I wanted to point that out. I said we were at equilibrium. We changed the temperature, so what I disturbed it. So we're not at equilibrium anymore. Okay? Now, we're just not at equilibrium anymore. It's going to get back there.
So you give an example of what would happen.
What would happen if we disturbed it? Now, what's going to happen? We increased evaporation.
We blow up.
We're not blowing up. Now, what's going to respond? How is it going to respond? What's the vapor going to do?
Condensate
Faster or slower?
faster.
Why?
I'm genius.
All right, so we have more vapor, right? You said we increased the vapor, so there's more vapor. So it will do what?
Condensate faster.
Okay, so we're going to condense faster.
What's the next one?
All right, now,
No, what's the next question?
hold on.
Y'all better not answer. I got it.
Now, if we condense faster, are we in equilibrium yet?
No.
No. We know we're not at equilibrium yet because did it tell us the rates were equal?
No.
No. Okay?
If you see me doing this at my test, just don't worry about it.
All right. Tell me when we are at equilibrium. How do you know you're at equilibrium again?
Because the temperature goes back to
Nope. What's the condition you need to be at equilibrium? Say it again, Sarah Lynn. All right. So,
That's the same as what I said.
no, it's not. You said the temperature had to go back.
Temperature same equals equal, rate equals temperature.
All right. Equilibrium is reestablished
Oh, equilibrium.
at a higher temperature.
Well,
All right. So equilibrium is reestablished at a higher temperature when the rate of evaporation equals the rate of condensation. All right. Did you write that down?
I was waiting until you're done because I thought you said equal, but it's equilibrium, and I was like equal.
Right, I was looking at that first too. I was like, what is that?
I just get tired of writing equilibrium.
Well, I spell it different every single time. So.
Oh my god.
Dang. My feet smell bad.
Then put your shoes back on so we don't have to smell
My
it.
feet were sweating.
So
So
that like
I had to take them off.
Mine smells bad as the yogurt.
And maybe they smell so bad because you're not wearing socks.
I don't wear socks with my slide on. Y'all know this.
That is disgusting.
My slide on bands.
It's very disgusting. She's gross.
I
And she wonders why they smell.
Don't smell these things because
I wouldn't want to even.
They are-
All right, we caught up? Now,
In that shoe, I
they're
would die.
black.
this ain't your feet dirty.
I mean, it's not dirty.
could we do the same thing if we lowered the temperature?
Yes.
So if we lowered the temperature, what would happen to the water?
Increase.
All right, we'd have more water. What would happen to our vapor?
Decrease.
Okay, so our rate of evaporation would, we have less evaporation. Our rate of condensation would go,
Up. Down.
yeah, because we'd have less vapor.
Yeah. Right.
Okay, so we'd have a reestablished equilibrium, but the rates would be higher or lower? Would we have a higher rate or a lower rate of evaporation and condensation? It'd be lower if you had a lower temperature. All right, let's start boiling.
No.
Yep, you don't have a choice. All right,
When they did this.
now when we talk about boiling, most people assume that this is just changing from a liquid to a gas, but it's not. Okay? All right. Now, you can keep in mind that the liquid changes to a gas, but there's a second piece to this that you have to know. Okay?
You're hold on, because you're writing way too many like short things. Oh, liquid to gas.
Really? L to G was too much?
I couldn't think.
And atmospheric pressure must equal equilibrium vapor pressure. Okay? Now, I'm going to draw a really tacky, ugly picture of a pot
That's what
on
Let me
another
draw it.
board to
I love
explain
drawing
this.
teapots.
All right, you draw a teapot. I'm going to draw a pot.
Oh, I thought I was gonna draw it for you.
No, I got this.
Draw
It won't be the most attractive pot, but it'll work.
These things smell bad.
All right, is everybody there? Yes? Don't hear your nose out there. All right, so it's not the most attractive pot on the planet, but it'll work for our. All right,
Baby, absolutely not.
now we need a stove. Sorry,
That's just all.
I can't tell if that's a teacup,
that's a pot.
pot to put ramen in.
Whatever, it's a pot to put ramen in. Now,
What is that little, is that a straw thing?
No, it's a little thingy to hold.
hold it, it's a handle.
No,
Now,
there.
Leave her. We're drawing it wrong. Don't look at
now, everybody knows as the water heats, all right, evaporation begins, right? And I'm pretty sure I can write evap if people know evaporation begins. Now, so you get little vapor molecules above the pot, right? Now, you could easily check this by putting your hand above the pot. I didn't say put your hand in the water. I didn't say touch the stove. All right, you put your hand above the pot, and how will your hand feel?
Smell it.
Yeah, probably if it gets really hot, but it will feel wet, okay? Because the steam is going to collect on your hands, so it's going to feel wet. All right, now, this moisture above the pot, all right, this vapor above the pot creates a pressure. It is called equilibrium vapor pressure. Okay? So every time you heat water, every time, as the water heats, evaporation is going to begin. Now, is this a closed system?
No.
No, it's not. So you're going to wind up with evaporated particles down here beside the stove. You're going to wind up with it above the stove, which is why you lose part of your water and it evaporates or vaporizes every time you heat water. Okay? So the vapor collects above the pot. When the water hits cool air, okay, so you've got cool air up here. All right, you've got cool air. All right. What happens when it hits that cool air up there? What does it do when it hits the cool air? That's right. The water vapor condensates and returns to the pot. Now, this evaporate, condense cycle happens repeatedly. All right, so water is going to continue to evaporate and condense over and over and over as the water heats. Okay? Now, when do you see bubbles? When does the water boil?
When it's hot enough.
Okay, not when it's hot enough.
Whenever it wants.
When you cover it.
Nope. Now, the air in the room has atmospheric pressure. For For those of you who ever watch the news or check your phone app for the weather, if you'll notice, it'll say barometric or pressure, okay? The average pressure in the room is roughly 1 atmosphere, okay? It varies depending on the day. If it's high pressure and it's sunny outside, it's 1 pressure. If it's rainy, it's low pressure. If you had earth science, they should have talked to you about high and low pressure.
Where it says.
Huh? Yes. But it ends in HG. There you go.
It's 30.13.
There you go. That's in inches of mercury. Now, the one that Joyce is looking at says inches of mercury. We learned it in what unit? Millimeters of mercury. We didn't do anything in feet. We did millimeter of mercury. 760 millimeters of mercury. Remember that? All right. In the States, we use inches of mercury, not millimeters of mercury. We could convert that if we needed to. We're not going to learn how. Okay? My point is that we have a pressure. Okay? So in order for this water to boil.
Miss Wall,
What?
we gotta squeegee this.
No, we don't.
It's a puddle of water on your desk.
On your
desk.
All right. So for the water to boil, the pressure above the pot exerted by the vapor must equal atmospheric pressure. Now, is atmospheric pressure the same every day? No. So does water boil at the same temperature every day?
No.
The answer is no.
Absolutely not.
We learned that water boils at 100 degrees Celsius. It's an average. So when you do the lab on Monday and you have to write down the boiling point, not everybody's going to get the same temperature. First of all, the thermometers are not all that accurate. Second of all, when you read the thermometers on Monday, the temperature is going to vary based on the weather outside and the pressure inside the room. Okay? So we're not all going to have 100 degrees Celsius. Now, if you write down 92 degrees Celsius, you wrote down the wrong temperature. Okay? If you write down 80, you wrote down the wrong temperature. It's going to be around 100. It might say 98. It might say 102. Okay? 100 is an average based on atmospheric pressure. So the atmospheric pressure in the room determines when it boils. Okay? The two have to be equal. Whatever the pressure in the room is has to equal the pressure above the pot. Okay?
You were right. I spread it out and it's dry quicker.
Now, if we consider the 3 regions of the state, all right, do we have the same elevation? No. So will we have the same pressures in those 3 areas? No. Will it affect boiling point and how fast we cook things? Yes, it will. Okay? Foods do not cook at the same rates in the 3 areas of the state.
Oh, yeah.
Okay? Because we don't have the same elevation. Where in the state would our greatest pressure be found? It's always the answer I get. It's always wrong.
The coast of Carolina.
Oh, for the Lord.
No.
Yes.
Guess what?
All right? The greatest pressure is in the coast. The lowest pressure is in the mountains. Now, if you would actually shut up, stop talking,
Sorry.
and listen, you would probably increase your grade by 10 points.
It wouldn't though, because
Maybe
Yeah.
two.
it might increase some.
Well, see,
If nothing else, you would annoy me less.
this is what I struggle with.
Now,
I pay attention so much. in
no,
that,
you don't.
and it's even lower in there, so.
Well, then try to do better in here and quit paying attention to there. I don't care. But shut up in here.
But like,
Now, if the pressure is higher at the coast and lower in the mountains, all right, where would you have the highest boiling point? Will the boiling point be greatest in the mountains or greatest at the coast?
oh,
I don't know.
No idea. Coach.
I don't even know what we're talking about. So.
That's because you've been talking over there.
First of all, I'm not
Now-
paying any attention at all.
Writing notes.
Then just hush.
I know, right?
That way you don't have to say I don't understand. Just don't pay attention, don't answer. So if you have a pot of water and you're boiling it and you have to reach the pressure before it will boil, all right? If we have to reach the pressure before it will boil, which one will have the highest boiling point? The one that has the lowest pressure or the one that has the highest pressure? The one that has the highest pressure. You have to get to the lowest pressure and it will boil at a lower boiling point. So this will have the lowest boiling point because you're going to reach that lowest pressure and then you're going to boil. If you have a high pressure, you have to get to that high pressure before you boil. So this will have a high boiling point. Okay, wherever that high pressure is, you got to get to that before you can boil. You can't boil till you get there. Okay, so it takes forever to boil water at the coast. It's going to boil faster in the mountains because it's a lower boiling point. It's a lower number. Okay,
Even if it's like, oh, like,
Snowy
Mountains?
yeah, you're you're at a higher elevation. It's all about elevation.
You would think the pressure increases with the elevation.
Nope, it's lower.
Really?
Yep.
Then how can we have to wear all that stuff whenever you?
Yeah. Now, where will food cook the fastest?
Coast. Piedmont.
Does it cook faster at a high temperature or low temperature?
High.
It cooks faster at the coast.
This is beyond.
Have any of you ever baked before?
Well, yeah, but like I was like.
Have you ever looked at the side of the box? All right. If you look at the side of a brownie or a cake box, if you don't believe it, go home and look. You have it in your cabinet. For higher elevations, do what?
Increase the temperature.
Increase the temperature or cook. It's like 10 minutes longer because it cooks slower. It doesn't cook as fast. All right. That's just death. I blew out her ear. All right. If you have cookies, brownies, cakes, and you're baking in the mountains, you have to cook it for a longer period of time, or it tells you to increase the temperature.
So
All
when
right.
you say coast, you're talking about like deep depths of the ocean.
I'm talking about the beach.
Okay,
I'm not. Underwater.
Well, I'm confused because the mountains have the really high pressures, or at least they make it seem to be. When you hike mountains, like when people go to Mount Everest, they have to wear all that oxygen and stuff because the pressure's too low. So I'm confused on how.
You just said the pressure's too what?
Low.
Too low.
I was thinking it would be too high, but
No, the pressure's too low.
And that's what whenever you
got it.
You should have thought about that.
No, I had to get it out. So I was confused. Yeah.
If you go down in the ocean, what happens to the water that pushes on you?
Died.
Because the pressure's too great. We don't generally cook underwater though. Just saying.
I mean, Ariel will be looking up in the
Okay.
the dingle hoppers.
Yeah. All right.
Smack.
The last thing we're gonna do.
Oh,
All right, the equilibrium vapor pressure graph. All right, we don't need to talk about reading temperature or pressure because everybody in here knows how to do it. All right, even Annabelle, who tells me she can't do anything in math, can read temperature and pressure. Okay, Even those little flyer things, nothing like that. You got this. Okay? If you need temperature, read up, over, pressure, read over and down. Now, the only thing we need to talk about is how to read normal boiling point. Okay? Draw a line at standard. Oh, I did them backwards.
I wrote this.
I did it backwards.
Boo.
And standard pressure. You know how many graphs I've run around in my head? I got a
Think
few.
about the movie Inside Out, and it's like obviously it's not real.
Whatever.
It's
No.
like
All right, so draw a line at standard pressure. Okay?
I have a lot of this. Just like the joy.
So, what would you have to know in order to draw a line at standard pressure?
Or like
How would you know what standard pressure to use? Yes, which one? So, what do we want to label our graph as? Y'all tell me. Okay? So, ATM. So, what's standard pressure for ATMs? All right, we'll just put it here for the sake of argument. Okay, so you'd have to know what unit, right? So, draw in a line across your graph. No, I'm just drawing it in dotted just to make it obvious. Okay? Find the intersection. And then read temperature. Okay? So, where's my intersection? Where the blue and the green meet, right? Right there. So that is the normal boiling point. And so you would do what? I heard somebody say it already. Just go down and find the temperature. That's all you have to do to find normal boiling point. Okay? You just have to find standard pressure. So if it was MMHG, you would have looked for what number? 760. You'd still draw a line across, find the intersection, and read down. Now, do you have the graph I told you not to lose yesterday? Now, your homework is that graph plus 2 questions. Oh, stop whining. A grand total of 2 questions. I don't think 2 questions at half a page are going to kill you. What? Yeah. Those of you who are not here tomorrow, make sure you get the opening. Say what? You're either saying increase or decrease. I don't think writing increase or decrease is going to kill you, Joyce. Just saying.
It might.
I mean, it might kill Annabelle, but I think the rest of y'all will be okay.
Life gets hard.
Faith might cry, but I think even Faith will be okay with this one. You just write increase or decrease, Faith. I'm sure. It's increase or decrease. You just gotta write increase or decrease. Then you gotta do the graph.
Give me that page, boy.
Check your answers on. Do you have before you come back? Okay. I don't want to tax you. Attack me? No, tax you too much. I know you got details. I don't want you to stress out and die.
Are you staying today?
No, I have a department meeting. Thanks to Ms. Curry.